as Taylor said, with FOAM. At FOAM, we're working on what we call proof of location. But for part of this talk, I wanted to touch on the importance of time synchronization and a little bit of the history there. So in the past, in physics, which just came out recently, like in Newtonian physics, it was considered that like time was completely absolute. But after kind of Einstein's discovery of relativity, this kind of came into our consciousness that time maybe is actually something that's relative. And if it's relative, then you can only really define it as a system of linked and coordinated clocks that are synchronized together. So even before that, we had synchronized clocks. There's something that Nick Szabo, someone very early in Bitcoin, called the canonical time. And so this is the idea of like in a medieval village, there's only one source of time, mostly the church, and they would ring the church bells. And so this was basically a public good, but also meant time was really fair. So if the church wanted to trick somebody that it was like 1 p.m. when it really wasn't, the whole town would hear the bells. So everyone would kind of have to organize themselves over this like one central source of time. And that kind of like helped organize society, getting us towards like work days and things like that. And so the top image is a navigation method. It was called dead reckoning. This is how people used to navigate with ships and try and get to America. With dead reckoning is vector based, so you can't map it to the Earth. It would just say like, go left for 5 knots, then turn slightly right for 6 knots, then turn left again for X knots. Etc. And so this was like ships would get lost or crash all the time. And so this was a big problem. And so a big award was put out to basically solve longitude of how could somebody figure out where they were on a longitude plane. And this was tied to then Greenwich Mean Time. So there was a special clock that was then invented that could withstand water and pressure. And so that was how people were able to then essentially localize themselves with time, syncing it to Greenwich Mean Time. And so that's just like a brief history of like how clocks has related to like localizations and things, as time and space are very interconnected. And as we got more electricity and synchronized clocks, this helped drive things like the railroads all the way to stock markets. And one interesting piece of lore is like when the Eiffel Tower was built, actually, Parisians really hated it. And it was actually set for demolition until it was realized that it was an amazing radio broadcaster. And I think in the early 1900s, they were able to broadcast across the Atlantic Ocean to Arlington, Virginia, the Naval Observatory, all the way from the Eiffel Tower. And so radio actually saved the Eiffel Tower from demolition. And even French colonies were able to then localize themselves and help produce maps with longitude by being able to localize themselves relative to the Eiffel Tower. So very interesting there. So fast forward though to all the way to today, we have something that's called GPS, a global positioning system.
Sorry, what's that?
Yeah. And GPS has unlocked an enormous amount of value today for different companies. Things like Google Maps, Uber, Yelp, Pokemon Go, Garmin trackers are all only possible with GPS. So GPS has unlocked an enormous amount of value for the economy. And there are tons of different sectors that use localization technology, all the way from asset tracking to different location-based services to mobility at large with cars. So yeah, GPS has been a major breakthrough and is amazing technology. If you don't know how it works, there are 24 active satellites. There's a bit more probably up there rotating around the Earth. And to be able to use the service, your receiver needs to hear at least 4 of these satellites. The reason you need to hear 4 is for X, Y, Z, and a 4th for checking time variance. In these GPS satellites, they all have these atomic clocks, and they are synchronized with ground stations. And so having synchronization at such a fine level translates to accurate localizations. And so they use a system that is like time difference of arrival. So your phone, if you've ever had this like blue dot moving around and it's not settled, it's because you can't hear enough GPS satellites. But this system is completely one directional. So users don't talk back to the GPS satellites. And it's operated by the Navy, and it's only their job is only to make sure that the clocks stay synchronized and the satellites don't crash into each other. So they're not responsible for how people use the system. And turns out it's actually kind of vulnerable. And so in recent years, we've been seeing a large increase in what's called GPS spoofing as well as jamming. Jamming is more straightforward. It's kind of broadcasting a radio signal that's louder than the GPS signal, so it blocks out GPS being used. There's been a few years ago mysterious like crop circles that appeared of like looking like ships were on land just going in circles. That was some sort of jamming. And currently there's a large jammer in Russia that's been disrupting airspace all the way into the Baltic and states. But on the spoofing side, that's like tricking systems. So because GPS is one directional and doesn't know anything about you, if you wanted to tell like Uber or Pokemon you were somewhere else, that's kind of trivial to do. And actually, we just heard about Helium in the last talk, and their IoT network, they're not able to solve spoofing. So people were putting, 100 radios in their basement and then having them broadcast to make it seem like they were spread out across the city. So it became more profitable to spoof than operate nodes correctly. And because it's such a difficult problem to solve, they operate a centralized blacklist, just banning people who may be spoofing. So when it comes to kind of monetary incentives in especially the blockchain space, connecting to the physical world has its challenges if it's so easy to lie about GPS data. So kind of as a summary, like GPS provides an enormous amount of value, but there currently are no backups or alternatives. It's not secure. There's a single point of failure, and the data isn't as valuable as it could be since there's no authentication happening. And this is now a known problem. The government has called for backups and alternatives to positioning, navigation, and timing. But it's kind of turned out that GPS does so much that there isn't a single service or entity that could replicate it. So after looking at 10 different companies, the Department of Defense said that there needs to be a new ecosystem of P&T solutions that are industry specific, since what GPS does is so wide and available globally. So what we're working at FOAM is tackling this spoofing aspect and trying to bring on-chain location data that has kind of a level of security behind it that you associate with blockchains and decentralized data. We have a terrestrial-based radio system. We call the radio zone anchors that can form a zone of coverage. And we use these time-of-flight algorithms to be able to localize the network itself and anybody in the network. So from a different point of view, this is an image of a zone. This is the Brooklyn Navy Yard where we're based. So you would have multiple zone anchors, we call them, spread out, that can all talk to each other, see each other. It's kind of like a local GPS. And then what's different about GPS is it's bidirectional. So as a user, I can actually talk back to the system over radio and request to have my location be produced. So the system can work independent of GPS. And localize users. As a blockchain project, there are economics as well for being a service level operator, and then a fee you could pay to generate the mint, which I can get into in demos. So I mentioned to form these zones of coverage, you need radios, and we call our radios zone anchors. This is our plug and play model. So we do use a radio that's called LoRa, which is a low power IoT network. But we also have additional components, namely an FPGA, which is essentially like a custom chip. And we use that for timestamping. Similar to the previous discussion, we need like a nanosecond level timescale to get localizations that are like 10, 50 meters at least. And so we need this additional hardware piece of the FPGA to do those timestampings. And yeah, this is our plug and play unit that we have 100 manufactured of and are currently testing. But in addition to hardware, we also work on a lot of software as well as firmware, and we kind of have a full stack to enable this proof of location. So on the right is a screenshot of our application called Hostel, which I have a demo I can show in a moment. And we use that to manage our radios. You can see everything from like how hot they are, how much CPU they're using, to ultimately what location proofs they've generated, what have you. We've also developed this software called Time Sync, that essentially tags all of the radio packets as they're coming in for our pipeline. And then we use something called a software-defined radio. So that's translating these radio packets from analog to digital and putting them through our localization pipeline. Yeah, so as I mentioned, we use FPGAs. That slide's actually not meant to be here. So that's a bit on what is FOAM and why we're building what we're building. In terms of where we are We've been building this for a number of years and are based in the Brooklyn Navy Yard. So we had our first test network there. And then in 2022, we had an open call for beta testers. We call it the Trust Zone program, since you would trust that the zone was there. That's not crypto backed. We had a number of teams participate and still have some zones up from that program, namely in San Diego, Austin, New Jersey, and New Zealand, actually. So in the previous slide is our plug and play model. But when we had this beta, that we had Raspberry Pi based nodes with a custom hat that had the FPGA on it. So people were organizing like build events to get these assembled and put them up in different regions. Part of the beta too is to test these radios in different regions. We were only testing in Brooklyn, so we wanted to see how it performs in like a rural environment or a different kind of city environment. These are just more photos of that build workshop in San Diego. There's different ways you can install the radios. So you could like just mount them on the side of the wall. But if you didn't want to drill into the building, you can use a non-penetrating roof mount, which is what's shown here. That's just weighed down by cinder blocks, so it doesn't drill into the building. There's one on the right that we have in New Jersey. And this is in the Brooklyn Navy Yard. So the one on the left is our Raspberry Pi one in a very cheap enclosure with some sort of heat protection foil on it. And the one on the right is our more powerful plug and play one, which there's more photos of. And so what we do like day to day is like run experiments. That's where we like turn the zone on and somebody's essentially walking around with a mobile transmitter. And maybe it's hard to see, but like in this example, we have like almost 2 meters off from GPS. So it is possible to get pretty accurate localization results, but it varies from zone to zone depending on how many buildings are around or things like that. But the main point of the system is that you couldn't fake that you signed this message over radio, not as much as how accurate it is. This is a much bigger zone across a town in near Newark, New Jersey. So we're getting localization results there. And more recently, we've been working on what we call the FOAM MVP. So our previous year's efforts has been in like the hardware, the firmware, testing the deployments. But we've been building the MVP is bringing things back on chain and having an end-to-end demo of how you could actually prove your location and mint that on a blockchain. So we've been building on what is called the Optimism stack, which is a layer 2 on Ethereum, but it's also a developer kit where anyone can spin up their own Optimism blockchain. So we have a developer network running where we have these zones that are up and on. So the idea with the Optimism stack is they're building something called the superchain. And the idea is that if everyone uses this, or anyone who opts into this developer kit has the same standards, so they can be very easily interoperable. So if you have many of these Optimism chains, they could talk to each other very cheaply and share data across them. So if there's a FOAM Optimism chain, you don't need all these applications to deploy on your chain. Data could easily move to the other ones, is kind of the idea. I might not have the slide for it, but we also integrate with IPFS. So every radio is like running an IPFS node. More specifically, we store data in IPLD and are researching custom opcodes for our OP chain for smart contracts to more easily parse IPLD. I guess I missed the slide for that. Sorry. Yeah, so there's a bunch of use cases that you can use proof of location for. This could be like your own private location passport. This could be NFT or gaming related. We're working on a demo game. If you've ever played the board game Settlers of Catan, this is like Settlers of the Superchain, where there are like game resources, but maybe you can only get one in San Diego and only one at the Maryland zone. So you'd either have to travel or trade with people. There's more in like insurance and supply chain, which is more traditional business, but for high value assets that want to have this verification, those are options. I have a how to get involved slide, but I also have a quick demo that I'm going to end with. I don't know how to get rid of the green box from Zoom. But this is our app in our zone in Brooklyn. And so if I was standing there and had my radio and press the button, the system would start to scan. And so the nodes turning purple are nodes that heard me. And if at least 3 can hear me, can generate a location, which is there. And then you can, I guess the demo's moving faster than I can talk. But then you can mint that as an NFT and essentially see which other radios countersigned it. And then you can get that on chain. This is showing all the ones I have minted historically. I think I covered a lot of ground, so I can pause there, and I guess we can all get to talking and networking. But I'm just going to try and get to my how to get involved slide. I don't know, the Zoom sharing might not be working. But yeah, we are currently still have people joining our beta in kind of a rolling manner. So if you're interested in getting involved, you need at least 4 essentially building roofs that have line of sight to each other. So the information is there, and a bunch of our contact information is on the right. We're going to have a renewed call soon for our plug and play models to join our testnet, so look out for that. But happy to talk any questions now or chat with everyone after. Thank you.
So you had mentioned something about using Chainlink on a previous slide. Could you elaborate a bit more about that?
Yeah, sure. I think I skipped over it on purpose because it was left over from the Chainlink meetup. But yeah, we've worked with them in the past on like when we had a mapping protocol to try and look at like off-chain data sets and compare what was on-chain to like find that difference.
So are you pulling data from like a Chainlink Oracle?
Yeah, in that one, in that demo, yeah.
Okay. But I just wondered, because I've worked with Chainlink before, and it could get very expensive very fast.
Yeah, that was one of the hangups of the demo.
Yeah.
Yeah, I'm just looking at the requirements here, and I was just going through the website form too, because this is really cool and would be interested in participating. That the requirements there seem to indicate a pretty specific kind of stakeholder that has 4 buildings they can put things on top of. So, you know, in thinking, like you mentioned, trying stuff in rural areas, so if I have one location, and I have a big radio tower on it already, is there a time or a situation where that might actually be useful, or does it always need the kind of cluster effect?
Yeah, I guess it depends how you define useful. So if like, let's say you had more than one up, but if I'm a user, only one's hearing me. So it's almost like you effectively have one up. So it's useful in that you can still sign a message over radio and have it relayed onto Ethereum. So we call it a witness. And it's useful that it can send other data over LoRa. So this is similar to what actually Helium's purpose is of just like LoRa data. So if you wanted to get some sort of sensor data onto Ethereum, then it's useful. But that's just the nature of the physics. So you need at least 3 to do like a triangulation. So that's not like a FOAM requirement. So you won't be able to get accurate localizations, but you could at least have like a witness and be like, I'm pinging it once a day. And so that's like an extra layer of verification that I've been witnessed by this entity. If then your node is very trusted or somehow had a trust score, then maybe people would say, yes, it's useful that people signed in with that one. But it won't be able to say like where you are near it, just that it heard you.
Yeah, real quick, do y'all provide hardware for the demo for the, I guess, test case?
Yeah, for the beta, we provided the hardware to people. Yep.
8 million questions.
Great. Ready for dinner.
Cut me off. How do you make money?
We had a token sale in the past.
Sorry, yeah, but like in general, like how do you monetize this?
Hardware sales or
Hardware sales. So how much
custom.
do your units cost? In general,
500.
$500, great. And then do I subscribe to, is it like a SASE DAOE thingamabob, or once I buy your thing, like, do I have to keep paying you in order to once I deploy it?
There's many different actors. So who would want to be paying me is maybe like the person who wants to use the network. the people running the network might not be the users. So
Yeah.
those people are getting paid by the people who want to use it.
Yeah,
And then maybe a port wants a custom use case, so now they want like specialized dashboards or specialized transmitters for their forklift.
right.
That's where we would make money.
And then the thing, just cut me off. The thing you walk around with, right, it's not a chip that's already in the phone.
No, it's
an
it's LoRa.
It's a LoRa, so I can just get a LoRa peripheral for what.
Yeah,
it is.
we're looking at like a phone case that has
Yeah.
it built in, but yeah.
Yeah, just think about guys at like NextNav, right, where they were actually working through getting, you know, a chip in all phones, right? That was the pacing thing. for
Yeah.
Deployment. Z, how good are you guys at Z?
Haven't had the resources to test in depth.
Because when you say line of sight from the roof, it makes me wonder, like indoors, does this break down indoors, based on the LoRa wavelengths?
This doesn't work with LoRa, so we're radio agnostic, so we could use a different radio indoors, but because you need that nanosecond paint, it bounces too much inside. The LoRa
Okay.
signal.
I've got a bunch of questions for you. That's great. Thanks, super cool.
Awesome, thank you.
How do you, like, how do you balance, because again, I feel like it's gotta be tough having hardware, firmware and software, so like, how do you balance that in capacity, team's focus as a founder?
It's been tough. You want to do more than you can, so we've not balanced it essentially. We've been like, okay, we're doing hardware. Okay, now we're doing blockchain. Okay, we've done the MVP of blockchain. Now we're going to our new hardware. So if we had 3 times the resources, maybe we could balance it, but we've been on like a one at a time kind of trajectory.
Any other questions?
Deployment of those mega communication constellations, which is happening pretty much right now. And Starlink is an example of this. A lot of constellations which are rolled to that. They will provide some level of redundancy. Yes, it's theoretically. Do you do some kind of analysis of how the market might look like in 3, 4, 5 years, and where you're going, and how? And that's one question. The second question is like, how is the scale up? Looking like for you? How many billion? How many devices would you need to replicate?
Yeah, great questions. For the first one, there are alternative positioning low orbit satellite systems, and some are looking to offer this bi-directional encrypted communication. So that may, offer the similar service, but it's still then completely centralized and controlled by one entity, which could be hacked or leaked, and you may not have as much flexibility with the data. So that's coming to the market, but seems to be some consolidation in the satellite space. So this one company, Satellus, was offering that, but they just got purchased by a bigger company. So I'm not sure. And similarly, Galileo is offering some authentication services, but it doesn't lead to that. You then have this like on-chain asset that proves something, and you can then go use it in a game or use it for a delivery system. So it doesn't unlock the same amount. And then you don't need scale. So you could just have this one zone in like Times Square, and it works there. And then we have economic system where people could signal where they want more coverage. So it's like it works anywhere there's coverage. And then if people want a lot of coverage, then we could hopefully get a lot of coverage. But you technically don't need like nationwide coverage. You could just have it in 3 cities, and the service will work. So then if you need scale, then we have to scale it. Yep.
Thinking about trying to automate decentralized entities